Hi everyone, welcome back. In this video, we are going to discuss top Java string interview questions and answers. Let's begin. What is a string in Java and why is it immutable? A string in Java is an object that represents a sequence of characters. It is stored in the java.lang package and is one of the most widely used classes in Java applications. What makes strings unique is that they are immutable. This means once a string object is created, you cannot change its content. Any modification such as concatenation, substring extraction or replacement creates a new string object instead of modifying the existing one. The immutability of strings plays an important role in memory safety and efficiency. Strings are stored in a special memory area called the string pool. Because strings are immutable, multiple references can point to the same literal safely. If strings were mutable, one thread modifying a shared string would impact other threads, causing unpredictable behavior. Immutability also allows strings to be used in security-sensitive areas like class loading, network connections, or file paths. It also improves performance by enabling caching and avoiding repeated calculations. Java relies heavily on strings for internal operations, so immutability ensures consistent and stable behavior. Next, what is the string pool and how does it work? The string pool is a special memory region inside the Java heap where string literals are stored. When you create a string using double quotes such as string s equals hello, Java checks the pool first. If an identical literal already exists, Java returns a reference to the existing object instead of creating a new one. This process is called interning. The string pool improves memory efficiency because many parts of an application may use the same literal values like OK, mail, admin. Instead of storing duplicate objects, Java stores only one and reuses it. This optimization works because strings are immutable, so sharing them is safe. If you create a string using the new keyword such as new string hello, it bypasses the pool and creates a new object in the heap. You can still move the string into the pool using the intern method, which ensures that the canonical version of the string resides in the pool. The string pool reduces memory usage, accelerates string comparisons, and improves overall application performance. Next question. What is the difference between equals and equals method when comparing strings? The equals operator compares whether two references point to the same memory location. It does not check the actual content of the strings. For example, if you compare two string references created using new keyword, the equals operator will return false even if the content is the same because the objects live in different memory locations. The equals method checks the actual character sequence inside the string. If two strings contain the same characters in the same order, equals returns true regardless of whether the references are different. For example, this code returns true because the content is identical. Next, why are strings considered immutable, but StringBuilder and StringBuffer are mutable? Strings are immutable because the designers of Java wanted a secure, thread-safe, and memory-efficient way to handle text. When you modify a string, Java creates a new object and leaves the old one unchanged. This ensures safe sharing and stable performance in multi-threaded environments. However, immutable strings are inefficient for frequent modifications, especially in loops or performance-critical sections. This is why Java provides StringBuilder and StringBuffer. These classes store characters in a resizable array which can be modified directly without creating new objects. When you append, insert, or delete characters, the underlying buffer is updated. StringBuilder is not synchronized and is faster, making it suitable for single-threaded operations. StringBuffer is synchronized and thread-safe, making it appropriate for multi-threaded scenarios. The combination of immutable strings for safety and mutable builders for performance gives developers flexibility while ensuring Java applications remain fast and secure. Next question. What is the difference between string, StringBuilder and StringBuffer? String is immutable, meaning its content cannot be changed once created. Any modification results in a new object, which makes strings ideal for constants, keys, configuration values, and any data shared across threads. Because of immutability, strings are stored in the string pool and reused. StringBuilder is mutable and designed for fast and frequent modifications such as building dynamic text, constructing SQL queries, or generating reports. It is not synchronized, so it performs better in single-threaded applications. StringBuffer is also mutable like StringBuilder, but adds a synchronization on its methods. This makes StringBuffer thread-safe but slower compared to StringBuilder. In summary, use string for constant or shared values, StringBuilder for high-performance string manipulation, and StringBuffer when thread safety is required. Understanding these differences helps developers choose the right class for memory efficiency and performance. Next, what is the purpose of the intern method in Java strings? The intern method creates or retrieves the canonical representation of a string inside the string pool. When you call intern method on a string, Java checks whether an identical string already exists in the pool. If it does, Java returns the reference to that pooled string. If it does not exist, Java adds the current string to the pool and then returns the pooled reference. This method helps ensure that strings with identical content share the same reference, which improves memory efficiency and speeds up comparison operations. The intern method becomes useful when working with large or repeated string values, especially in applications that handle millions of identical strings such as data parsers, configuration systems, or log processors. Next question. Why is string considered thread-safe in Java? String is thread-safe because it is immutable. Once a string object is created, its internal character array cannot be modified. No matter how many threads use the same string instance, none of them can change its content, which eliminates the risk of race conditions, corrupted data, or inconsistent states. This immutability allows strings to be shared freely between threads without synchronization. For example, when multiple threads process common values like status codes, file paths, URLs, or JSON keys, all threads safely reference the same object from the string pool. Java's internal usage of strings also depends heavily on this immutability. Components such as class loader, security APIs, hatch map keys, network libraries, and reflection APIs use strings for configurations and identifiers. If strings were mutable, malicious code or faulty threads could alter these values and break the system. Thread safety through immutability also enhances performance because Java does not need to lock or synchronize string operations. The combination of immutability and pooling makes string one of the most optimized and reliable classes in the Java ecosystem.